Okay. When we divide with fractions, we multiply by the reciprocal, meaning we turn this to multiplication and we turn the second fraction upside down. So I'm going to do that, and so that's going to give me x squared plus 8x plus 16 over x plus 3. That part stays, x minus 3. That part stays the same. But we're going to turn this into a multiplication problem here, and we're going to turn this upside down. So this will be 3 minus x. That looks a little strange. I'm going to come back to that in a minute. But I'm going to put this in the denominator, x squared plus 12x plus 32. Now let's deal with this 3 minus x business. When you have terms that are backwards, meaning if you have a binomial that's not in standard form. So for example, say if I have 5 minus x. Well, first of all, what if I had 5 plus x? Well, if I had 5 plus x, I could just switch these around, and I could just write x plus 5. All right, those are equivalent. But on the other hand, imagine that I had, and I'm going to change the numbers now. Imagine that I had 4 minus x. Could I just switch these around and put x minus 4 instead? No, I could not, because looking at the original problem, the 4 is positive. Now I've made it negative. That's no good. The x is negative, but now here I've made it positive. So if I'm going to switch these around, the negative would have to stay with the x, and the 4 would have to stay positive. Now, I don't like there being a negative leading coefficient when I'm trying to factor, so I would want to factor out that, that negative 1 and put x minus 4 like this. Okay, so notice the pattern. I have 4 minus x. Now if I reverse these and put x minus 4, I have to have this negative outside. So I want you to be able to do that in one step though. So imagine that I have 7 minus n, for example. This is going to, if I switch these around and put n minus 7, that's going to be valid as long as I remember to put an extra negative out front. Okay, and the step that I'm skipping is that really this is negative n plus 7, and then I'm factoring out the negative 1. Okay, so that is some crucial business. Let's practice that one more time. Say if I had 6 minus y. This is not in standard form. I can write y minus 6 as long as I put a negative out front. Okay, so that will often come in handy. So I see that I have this 3 minus x. So what can I do to put it in standard form? I can write x minus 3, but I'm going to have to put a negative outside of the parentheses. So you should do that. Otherwise, you won't realize when you have like factors that need to cancel. Okay. Now I need to factor everything else. So looking at the numerator here, I really want to factor that. And I see this denominator over here. I want to factor that. So let's see. I have my negative x minus 3. I have this x minus 3 over here. Let's see. This trinomial. Let's factor that. X squared will be x times x. 16 is going to factor as 4 times 4. All right, positive and positive. Looking at this trinomial here, that's going to factor as a binomial times a binomial. X squared is x times x. 32 Alright, 32 is probably going to be 8 times 4. Positive and positive. So now I have factored everything out. Okay, now before I get too carried away, before I start canceling everything out under the sun, let's talk about restrictions. Remember, when you're doing a division problem, the restrictions, the excluded values, come from 3 places: here, here, and here. All right, all 3 places. So okay, so I'm looking in the denominator here, but in the second fraction I'm looking in the numerator and the denominator. So looking at this x minus 3, that tells me that x cannot equal positive 3. Okay, I got that from, if I set x minus 3 equal to 0, I get positive 3. So x cannot equal 3. Alright, now I'm going to slide over and look at the denominator here. If I set x plus 8 equal to 0, that tells me that x cannot equal negative 8 because of this. If I set x plus 4 equal to 0, that tells me that x cannot equal negative 4. And if I set x minus 3 equal to 0, that tells me that x cannot equal 3, but I already have that. So these are my 3 restrictions, my excluded values. Now let's look back and talk about what will cancel out. So I'm looking at this like it's one big fraction at this point. Now anything I highlight, it means that that cancels out. Okay, so let's see. I see this x minus 3 in the top, and I see this x minus 3 in the bottom. So those will cancel out. Those are gone. Now I see x plus 4. So let me change colors to make it clear. Alright, I see, doesn't matter which one of these, but you can only cancel out one factor at a time. So this x plus 4 is going to cancel out one of these x plus 4s. It doesn't really matter which one I pick. Alright, so those are going to cancel each other out. Notice I can't take this 1x plus 4 and use it to cancel out both of these. One factor cancels out one factor. So that leaves x plus 4 in the numerator, x plus 8 in the denominator, and don't forget about that negative sign. It's still there in the numerator. Okay, so when I slide over to recopy this, okay, so I've got this fraction, and I have x plus 4 in the numerator, but don't forget about the negative sign. I canceled out the x minus 3, but the negative sign is still there. And then I have the x plus 8 in the denominator. Okay, so this is the answer, and these are the excluded values. Let's see, I shouldn't leave parentheses in my answer, so a better way to write this would be to have negative x minus 4. Just go ahead and distribute that minus sign over x plus 8.